Hey friends, so our next sort of lesson that we're going to talk about today is integration by partial fractions. Now, this is right after I spent the day doing trigonometric substitutions with you. I think personally this is actually easier. I feel like this is more straightforward than the trig substitutions. I'm curious to see how you feel at the end of it. So maybe we'll take a poll. You guys can send me an email and tell me which one you like better, which one is more easier. Okay. Okay, so we're going to have to review very quickly because you guys have done this in different contexts, but we're going to quickly review long division. If I had 3x cubed plus x squared minus 1 all over x plus 2, and I want to divide that by long division. The x plus 2 is outside, and inside is the 3x cubed, the plus x squared. Notice I have a 0x there as a placeholder because every degree has to be represented. I have to go degree 3, degree 2, degree 1, degree nothing. So then in my degree nothing, I've got the -1. Okay, so now the name of the game is I want to put something up here so that when I multiply by x plus 2, I get rid of the 3x cubed. I'm always looking for what can I get rid of at the left. You want to make the left part disappear. So I need a 3x squared because I know that a 3x squared times x will give me the 3x cubed. Now it's not just 3x squared times x, I also have to multiply that by the 2. So there's a little collateral damage happening here. My 3x squared goes on the front. 3x squared times x is my 3x cubed that I wanted, but then I also have 3x squared times 2, which is 6x squared. Okay, so that gives me 3x cubed plus 6x squared. And now I want to subtract those. So 3x cubed minus 3x cubed is nothing, which was the purpose, right? I wanted to get rid of what was on the left. And then x squared minus 6x squared gives me -5x squared. Now I drop the rest down and I start playing the game again. What do I want to put up here so that when I multiply by x, I get -5x squared? Well, I need a -5x. Okay, I'm just going to hide myself for a second so I can make sure you guys see all of that. So I stick the -5x there. -5x times x gives me -5x. Squared, that's a little typo. That should be a squared there, okay? Let me just add that in for you. Okay, and then -5x times 2 is -10x. Then I subtract. 0 subtract -10x is 10x, okay? So now I'm saying, what do I need to put up at the top? That when I multiply it by x, I get 10x. I know that that's a 10. Okay, so I'll hide myself again for just a quick second. I throw the 10 there. 10 times x is 10x. 10 times 2 is 20, and then I subtract. So I end up with -1 minus 20. I get a remainder of 21. So my final answer here would be 3x squared minus 5x plus 10 with a remainder of 21, -21, okay? All right, so that's exactly what I just said there. 3x squared minus 5x plus 10 minus 21 over x plus 2. That remainder never got divided by the x plus 2, so it's still over the x plus 2, okay? Now, each one of these has parts to it, and that lends itself to what we call a division statement here. So I just want to get that 2 gone, sorry. Okay, so I end up with p of x over x minus a equals q of x plus r over x minus a, where p of x is the dividend, x minus a is the divisor, q of x is the quotient, and r is the remainder, okay? All right, now, the other little thing we have to review before we can put these little pieces together, if I asked you to integrate 1 over x plus 3, I would want you to be comfortable to say that that's the ln of x plus 3. Okay, so ln, absolute value of x plus 3, plus c. If I asked you to integrate 1 over x minus 1 all squared, okay, that one's not as straightforward. It's a little bit more complicated, but that's still doable. I want to think of that as maybe x minus 1 to the -2, right? And then that degree is going to come up 1 degree. So, and I have to divide that by the front. So that'll be -1 x minus 1 to the negative 1. So in total, that would be negative 1 over x minus 1. Okay, like that, negative 1 over x minus 1, and then plus c. So yeah, a little bit more complicated, but still doable. Okay, so now with this guy, there's another little added layer of complexity here. If I want to integrate this, well, I can see this as 1 over x, and I know that the integration of 1 over x would be ln of x, right? So then I'm thinking, okay, well, this is the ln of 2 minus 3x, and that's great. But then when I go to check that, it doesn't work, because if I took the derivative of the ln of 2 minus 3x, I would get 1 over 2 minus 3x, but then I'd have to multiply it by that inside function, which is actually negative 3 here. So I actually need to introduce in my integration a coefficient that will counteract that negative 3. So how do I counteract that negative 3? Is with a 1/3. So the integration of 1 over 2 minus 3x is going to end up being negative 1/3 ln of 2, the absolute value of 2 minus 3x plus c. Okay, so again, another layer of complexity here, but still something I can kind of just talk myself through. I can deal with it in my head and a piece of paper and just my knowledge of integrations, creating something that then I want to take the derivative of to get back to what the original question was. Like just kind of going through that cycle, I can figure all that out. Okay, but now we have this last guy, which it's really not as easy to do what I just did, right? Because if you think about this, the derivative of the inside function, like you've got that x squared plus x. If I was to take the derivative of that, that would be 2x plus 1. It just gets a little messier, okay? So this is where we're going to introduce integration by partial fractions, okay? And there's kind of 3 types that I want to walk you through. So we'll go through each type, we'll do an example together, and then I'll set you loose to practice. Okay, so how do we do something like this? Okay, so type 1. Type 1 is when the denominator is the product of distinct linear factors. So the degree of the numerator is less than the degree of the denominator. So I have a higher degree on the bottom. And I essentially am going to want to try and factor it. But just to show you how this works first, if I was to add these guys together, okay, if I was to add 2 over x minus 1 plus 3 over x plus 2, well, I would need a common denominator. My common denominator is x minus 1 and x plus 2. So I would need an x plus 2 over x plus 2 on this guy, and I would need an x minus 1 over x minus 1 on this guy. So that would look like that. And then if I cleaned all this up, I'd go 2x plus 4 plus 3x minus 3. And then my 2x and 3x is 5x, and my 4 minus 3 is 1. So I end up with 5x plus 1 all over x minus 1, x plus 2. Okay. So now what we want to try and do is figure out how I would start with something, how I would start with something that looks like this and get it back to those fractions here, okay? Because if I had those two separate fractions are actually way easier to integrate, okay? So that's what I kind of want to look at. All right, so here's what we do. In order to integrate, we need a way to split the fraction up into separate integrals. So somehow we want to take 5x plus 1 over x minus 1 times x plus 2 and integrate it into something that's over x minus 1 plus something that's over x plus 2, okay? So we need a method of determining what those numerators are, and this is what's going to happen as I walk you through. So we're going to take 5x plus 1 over x minus 1, x plus 2, and we're going to separate it into a over x minus 1 plus b over x plus 2, where I don't know what a and b is, okay? So I'm going to take that a over x minus 1 plus b over x plus 2, and I'm going to just start adding them together. If I added them together, this guy would need the x plus 2, just like I was doing on the other slide. So I'd have to multiply that guy by x plus 2 over x plus 2. I'd have to multiply this guy by x minus 1 over x minus 1. Okay, that would give me a common denominator of x minus 1, x plus 2. And so once I have a common denominator, I can just pull the numerators out, and that's what I've done here, okay? Okay, so now I've got ax plus 2a plus bx minus b when I expand. So 5x plus 1 is ax plus 2a plus bx minus b. Okay, now I'm going to just group the x's together and the non-x's together. Okay, that way I'll be able to factor out an x from the ax plus the bx. Okay, so what I've done here is I grouped my ax plus bx together and I factored out the x. And then in the same breath over here, I didn't actually need to put this in brackets, but I was just trying to show you what's in front of the x is a 5. Here, what's in front of the x is an a plus b. Well, that tells me that a plus b has to be 5, right? It also tells me that 2a minus b, because these guys don't involve the x, 2a minus b has to be 1, okay? And so now I get these two little equations that say 5 has to equal a plus b, and 1 has to equal 2a minus b. Well, that's just the system. Okay, so now I'm just going to go ahead and solve the system. Okay, so if I go to solve the system, you can do it by substitution or elimination. I'm actually set up quite nicely here to do elimination because I've got a positive b and a negative b, so I could just add them together. Okay, I'll just get rid of the ink there. So that would give me 6 equals 3a, and a would have to be 2. Now that I know that a is 2, I plug it back into one of the original, and I get that b is 3. And so now I know that I can integrate the integration of 5x plus 1 over x minus 1, x plus 2 can be the integration of 2 over x minus 1 plus 3 over x plus 2, the integration of that. Okay, now those are actually really easy to integrate, right? This becomes 2 ln of x minus 1 and plus 3 ln of x plus 2 plus c. Okay, so once I have it into those smaller fractions, the integration portion is like super, super easy. Okay, this technique of taking a single rational expression and making it into 2 or more equivalent parts is called the method of partial fractions. Okay, I go from one large fraction to 2 partial fractions. Okay, now method 2 is when the denominator is the product of repeated linear factors. Okay, so now for this guy, it's a very similar process. For this guy, I want to look at what 3 over x minus 3 plus 4 over x minus 3 squared would be. Well, for this guy, my common denominator would be x minus 3 squared, and I only need that on the front fraction. So I'm going to take the front fraction, multiply both by x minus 3, and that would give me 3 times x minus 3 plus 4 over x minus 3. Okay, now that's 3x minus 9 plus 4, which is 3x minus 5 over x minus 3 all squared. So now the name of the game is, how do I go from there back to there? That's what we're trying to figure out, okay? And the trick with this one is when I have the same factor squared, I'm going to break it into that factor squared plus that factor to a degree 1, okay? All right, so in order to integrate, we need a way to split up the fraction into separate integrals. So the same sort of setup, I want to try and split this up into x minus 3 for one of them and x minus 3 squared for the other guy, okay? So the process that I walked you through with method 1, pretty much the same, okay? I'm going to have a for the first guy, b for the second guy. I know I need to multiply this guy by the x minus 3. Okay, so essentially I'm multiplying everything by x minus 3 squared, or I'm getting a common denominator and then pulling the numerators. It doesn't really matter how you look at that. I know in the first example, I said multiply everything by the LCD, and then in my description, I was actually getting a common denominator and pulling the numerator. It's the same thing, doesn't matter, okay? Don't let that stress you. So multiplying everything by the LCD or getting a common denominator and pulling numerators will leave you with 3x minus 5 equals x minus 3 plus 1b. Okay, so that's going to give you ax minus 3a plus b. And again, this gives me two little equations. I know that ax has to give me 3x, right? So that tells me a has to be 3. And it tells me that -5 has to equal -3a plus b. Okay. So a is 3, -5 equals -3a plus b. I can plug 3 right away in there and solve for b. So I end up with b being 4. Okay, and then once I know that, I know my two fractions, and it's pretty darn easy to integrate. Okay, so when I go to integrate this, I know that this guy is going to be 3 ln of x minus 3. This guy will be 4. But now remember, this was similar to the example that I gave when we started kind of my intro examples, that x minus 3 is like x minus 3 to the -2, right? So the -2 goes up to be -1. So 4 gets divided by -1. So that's going to end up being -4 over x minus 3. And then I have my plus c there as well. Okay. Awesome. Okay, the only problem with non-repeated irreducible quadratic factors like x squared plus 1 in the denominator, so if I was to integrate something like that, it leads to inverse trig functions like tan to the -1 of x, and we don't want to get into that one, okay? All right. Type 3 is when the degree of the numerator is larger. Now, when we do that, the way we split them up into two parts is we just do long division, like I started with at the beginning. So I've got x plus 5 over x minus 7. I'm physically just going to do that long division. X minus 7 on the outside, x plus 5 on the inside. Okay, I have a 1 on the top. 1 times x minus 7 is x minus 7, and that leaves me with a remainder of 12. 5 minus -7. Okay, so now I can split this x plus 5 over x minus 7 into 1 plus 12 over x minus 7, which is way easier to integrate because that's the integration of 1 plus the integration of 12 over x minus 7. The integration of 1 is x. The integration of 12 over x minus 7 would be 12 ln x minus 7, and then plus c. Okay? So really not that bad at all. All right. Last example of our time together today, we want to integrate 3x cubed minus 8 over x squared minus 4. Now, the first thing I want you to notice is the degree on top is larger. So if the degree on top is larger, I'm going to start by breaking this up into two fractions using long division. So I've got my x squared minus 4 on the outside. And then I've got my 3x cubed. I'm going to need a 0x squared, a 0x, and then a -8 on the inside. What do I put up here so that when I multiply it by 3x squared, I get out 3x cubed? Well, I need a 3x on the top. So 3x times 3x squared gives me 3x cubed. And then 3x times -4 would give me -12. So then when I subtract, I end up with 12x minus 8. There's nothing else I can put up here. That is going to have to be my remainder. And so I've now been able to break this down into two separate integrations, the integration of 3x plus the integration of 12x minus 8 over x squared minus 4. Okay, now this guy is method 1, where I can factor this into x plus 2 and x minus 2 on the bottom. So I'm going to want to try and split my 12x minus 8 over x plus 2, x minus 2 into two different fractions where one denominator is x plus 2 and one denominator is x minus 2. Okay, so here I go. I have a blank slide. There we go. Okay, so I'm going to split that up. I'm just going to deal with this 12x minus 8 first before I split the whole thing up, okay? So I have 12x minus 8 over x squared minus 4 equals a over x plus 2 plus b over x minus 2. This is going to be a times x minus 2 plus b times x plus 2. So I end up with 12x minus 8 equals ax minus 2a plus bx plus 2b. Put your a and b's together and factor out the x. And then put your non-x's together so that we can create those two statements, one that involves x and one that involves not x. So I know that 12 will have to equal a plus b, and negative 8 will have to equal negative 2a plus 2b. Okay, so now I'm going to go ahead and solve that either by substitution or elimination. It doesn't matter. Okay, I decided I was going to take the top one and multiply it by 2 so that I could eliminate. Okay, when I do that, I ended up adding them together. So 24 minus 8, adding negative 8, sorry, is 16, and 2b and 2b is 4b. That tells me that b has to be 4. And then going back, if b is 4, a has to be 8. Okay, so now I have my essentially 3 different statements. I've got 3x plus I've got 8 over x plus 2 and plus 4 over x minus 2. Okay, so I have these 3 separate integrations: the integration of 3x, the integration of 8 over x plus 2, and the integration of 4 over x minus 2. The integration of 3x will be 3 over 2x squared. And then I have 8 times ln of x plus 2, and I've got 4 times ln of x minus 2, and then plus c. Okay, so that will be the integration that I was seeking. Okay, super awesome. All right, so here is your homework for today. As always, make sure you're connecting with me and asking any questions that you have. Okay, you got this, guys. Good job.